Hi, and welcome to this new video in the series on Bluetooth Low Energy technology. My name is Mohammed Afani, and in today's video we'll be covering an introduction to Bluetooth Mesh, one of the most exciting updates released for Bluetooth technology. Some of the topics we'll address in this video include the basics of Bluetooth Mesh, the different terminology used in Bluetooth Mesh including nodes, messages, publish-subscribe, models, and scenes. The Bluetooth Mesh specification was released in July of 2017. The goal was to increase the range of Bluetooth networks and add support for more industrial applications utilizing Bluetooth Low Energy technology. Earlier versions of Bluetooth supported two different topologies: one-to-one, specifically when two BLE devices are connected to each other; one-to-many, with BLE devices in the broadcast state such as beacons; and with Bluetooth Mesh a new topology is introduced. Devices can now operate in a many-to-many topology, or what's called mesh. In a mesh network, devices can set up connections with multiple other devices within the network. Bluetooth Mesh builds on top of BLE. It specifically utilizes the advertising state of BLE devices. Devices within a Bluetooth Mesh network do not connect to each other like traditional BLE devices do. Rather, they use the advertising and scanning states in order to relay messages to each other. The Bluetooth Mesh standard defines how different devices operate within the network based on their roles. These devices include both live-powered and more power-constrained ones that need to run on batteries. A few important notes regarding Bluetooth Mesh. First, it supports all versions of Bluetooth Low Energy, going back to Bluetooth version 4.0. However, it is a separate specification and standard that's not part of the official Bluetooth specification. This is including Bluetooth 5 as well, and currently, as of the recording of this video, Bluetooth Mesh does not support the new Bluetooth 5 features such as extended advertisements and the long-range mode. Let's go over some of the most important terminology within Bluetooth Mesh. Devices that are part of a Bluetooth Mesh network are called nodes, and devices that are not part of the network are called unprovisioned devices. Now, once an unprovisioned device gets provisioned, it joins the network and becomes a node. A node may contain multiple parts which can be controlled independently. For example, a light fixture may contain multiple light bulbs which can be turned on or off independently. These different parts are referred to as elements. Here are some other terminology used in Bluetooth Mesh. States, for example, on and off states in a light bulb; properties, which add context to a state, such as outdoor versus indoor temperature in a temperature sensor; and state transitions, which define the change from one state to another. These can happen either instantaneous or over time. Nodes within a mesh network send messages to each other. Now, these messages are used to control a node, relay information between nodes, or to report status to each other. Message types are defined via unique opcodes or operation codes. There are two categories of messages. Those include acknowledged messages, which require a response from the receiver node or nodes, and unacknowledged messages, which do not require responses. Responses serve two purposes. They allow confirmation of receipt of the message, as well as sending back data related to the message that was received. Though there are three types of messages, and these include GET messages, which request a state from a node; SET messages, which change the value of a given state; and status messages, which serve as responses to a GET message, a SET message, or simply triggered independently via a timer. Addresses identify the source and destination of a message, and messages must be sent to and from an address. There are three types of addresses in Bluetooth Mesh. The first is called the unicast address, which uniquely identifies a single node and is assigned during a process called the provisioning process. Second, we have a group address, which is used to identify a group of nodes. These can be either SIG fixed, which are defined by the Bluetooth SIG, or dynamic addresses, which are defined by the user via a configuration application. Now, group addresses in general reflect a physical grouping of nodes, such as all nodes within a specific room in a house. The last type of addresses are virtual addresses, which may be assigned to one or more elements spanning one or more nodes. Here's an example of a mesh network in a home that's comprised of 6 switches and 9 light bulbs. The network utilizes the publish-subscribe method to allow nodes to send messages to each other. Publishing is simply the act of sending a message, and subscribing is the configuration to select messages sent to a specific address. Now, nodes may subscribe to multiple addresses, such as Light 3 in this example. It is subscribed to both the kitchen and the dining room group address. Also, multiple nodes may publish to the same address, such as switches 5 and 6 in this example. Those 2 switches control the same group of lights which are located in the garden. The benefit of using group or virtual addresses is that adding or removing nodes does not require reconfiguration of the other nodes. Another important term in Bluetooth Mesh is the concept of a model. A model defines some or all functionality of a given element. Now, there are 3 categories of models. First, we have the server model, which is a collection of states, state transitions, state bindings, and messages which an element containing the model may send or receive. Next, we have the client model. This does not define any states, but rather it focuses on the messages such as the get, set, and status messages sent to a server model. And lastly, we have the control model. The control model contains both a server and a client model, allowing communication with other server and client models. The models can be extended to include additional functionality instead of modifying the original model. A model that is not extended is called a root model. The final concept we'd like to cover is the concept of scenes in a Bluetooth mesh network. A scene is a stored collection of states. It is identified by a 16-bit number, which is unique within a mesh network. Now, scenes allow triggering of one action to set multiple states of different nodes in the network. They can be triggered on demand or timed at a specific time. For example, a scene may be configured to set the temperature of a dining room to 72 degrees and the living room lights to a certain brightness level and the window blinds to close. Triggering just one action, in this case, would trigger all of these state transitions. In the upcoming video, we'll continue covering the topic of Bluetooth Mesh. We'll go over some other terminologies and concepts within Bluetooth Mesh, including types of nodes in a Bluetooth Mesh network, the architecture of a Bluetooth Mesh network, as well as how it handles security. To learn more about Ellisys, provider of the world's most advanced Bluetooth analyzers, visit Ellisys.com. Have a need for training or design services? Then contact our training partner, NovelBits, at novelbits.io. I hope you've enjoyed watching this video and learned a little bit more about BLE. Thank you for watching, and I'll see you in the next one.